Okay, here we're going to be talking about our outcome measures or our dependent variables. So we're going to talk about the validity and reliability of those measures. We're also going to talk about direct observation, and then we're going to talk about effect sizes. So with respect to validity and reliability, there are 5 main objectives. We want to be able to recognize various tools of measurement. We want to understand what is meant by reliability. We want to be able to evaluate the reliability of a measure, understand what is meant by validity, and be able to evaluate the validity of a measure. So we've already learned about internal and external validity of a study. Now we're going to learn about reliability and validity of a measure. Don't get confused. Even though they both use the terms validity, they use the term in a slightly different way. In other words, when evaluating a study, we discuss the internal validity and the external validity. So the internal validity is how much control we had over the study, and the external validity is how that study is going to generalize to a larger population. When evaluating a measure, we discuss the reliability of the measure and also the validity of the measure. We're learning about this process now. So what is reliability? It's the consistency of your measurement instrument. For example, we want to look at the long division scores of students. So we need to have a measurement that is consistent across so we want a measure that is going to reliably give us the same score each time. It is the degree to which an instrument measures the same way each time it is used under the same condition with the same subjects. So what do I mean by this? It's any tool used to measure. So what in the world is a measurement instrument? It's any tool that is used to measure how heavy the apples are, how hot the meat is, how much orange juice there is, how tall the wall is. And some of these we can use a scale, we can use a meat thermometer, we can use a measuring cup, we can use a yardstick. So how does that relate to what we're doing? This is going to measure the size of someone's foot. It's going to be pretty reliable. This is going to look at eyesight. I don't know how reliable those things are because I can fool them, even though my eyesight's not very good. And we can look at the perfect amount of spaghetti, though I don't really know how that I guess you put the spaghetti in that, it doesn't matter. So we can also look at distance. We could use a measuring tape, an odometer. We could measure it out on a map, or we could walk it with a pedometer. Or we can get really creative, count paces, use a distance wheel, etc. So some of these are going to be more reliable than others. Obviously, the measuring tape is going to be really reliable. The odometer is going to be relatively reliable. However, the same thing with a distance wheel. We're only going to get as far as the diameter of the wheel. So if the wheel is 3 feet in diameter, we're going to get within 3 feet, and that's going to be the same with an odometer because these work on the same principle. On a map isn't going to be all that reliable because we're not going to be able to get within inches, and pedometers are pretty unreliable because the length of each step is going to vary, which means that everything's going to vary. So what instrument you choose depends on several factors. The ease of the use, do you know how to use it, access to it, the appropriateness of it, is it the tool for what you are measuring, the accuracy of it, and the cost of it. So obviously some of these are going to be less cost, but they might skimp on, because we can count the number of steps on our iPhone. However, it's not going to be the most reliable measure. It'll measure the amount of steps, probably, but you could also sit there and shake your iPhone and make it seem like you have more steps. So it's not the most reliable thing. So reliability is the consistency of your measurement instrument, the degree to which an instrument measures the same way each time it's used under the same condition with the same subjects. So if we're using a ruler to measure a book, what do you think would happen if you waited 10 minutes and measured the book again? How long would it be then? What if you spun the ruler around and shook it up really good? Is anything going to change? Probably not. So our ruler is generally consistent. It's measured the same way each time. It was used under the same condition with the same object. The book did not change, and therefore the ruler reported back the same measurement. So this is a reliable thing. What happens when we talk about other things? Every time I use a little plastic cup, that should say cup, I have 2 tablespoons of medicine. These measurements are reliable given the same temperature, time, and volume. They measure the same thing consistently. Every morning Margie gets on the scale, and every morning it reads 165 pounds. It seems pretty reliable since Margie hasn't gained any or lost any weight. One day an elephant got on the scale and it read 165 pounds. Is this scale reliable? Probably not. What about this? The clock reads 6:15. If nothing changes, if time stands still, will the clock still say the same thing? Yes, it's pretty reliable. You always know exactly what it's going to say. The problem is, even if the time doesn't stand still, the clock will not move, but it is still reliable. So what about validity? Validity asks if an instrument measures what it's supposed to, how true or accurate the measurement is. These instruments are very reliable. They both report consistently. But neither measures what it is supposed to. The scale is not really measuring weight. The clock is not measuring time. They are not valid because when the elephant stepped on this, it didn't do anything. And this clock is broken, so it always says 6:15. So it's not a very valid measure. So a ruler is not really reliable, or a ruler is not really valid if it can't measure how loud the radio is or how full the glass is. It can kind of do the glass thing, but we would be expecting then that each glass would be the same. It also can't measure how smart the girl is, so it's not very valid in those instances. Every instrument can be evaluated on 2 dimensions: how consistent it is given the same conditions, and if it measures what it's supposed to and how accurate it is. Imagine that I have 3 fish tank thermometers, a blue one, a red one, and a green one. The blue one always reads the same temperature no matter how hot or cold the water is. The red one shows a different temperature every time, even if I just measured it 5 seconds earlier. The green one seems to read accurately, warm when the water is warm and cold when the water is cool. So we can look at whether or not these things are reliable and valid. Is it consistent? Yes. Red wasn't. Is it measuring what it's supposed to? No. Blue is always doing the same thing, so it's reliable but not valid. This is not reliable or valid, and then this is reliable and valid because the thermometer changes if the temperature changes. What can be said of the reliability and validity of the following? A spelling test with the following item: 2 + 5. Probably reliable. If you get it wrong once, you probably get it wrong again. It lacks validity because it's a math test, not a spelling test. An elastic ruler. Every time you use it, it stretches to a different length. It lacks reliability, and then you can't have validity without reliability. A thermometer used to measure volume. Probably reliable, but it lacks validity for this task. And a scale that reads 40 pounds at baseline is reliable, will consistently be 40 pounds off, and it's not valid. Consider the Peabody picture inventory. Is it reliable? If you don't know the vocabulary today, are you going to suddenly know it tomorrow or next week? Probably not. So we'll say it's reliable. Imagine someone wanted to use it as a measure of cognitive development. Is it valid? Well, there are a lot of ways to operationalize cognitive development. Some might say that it is a better measure of English language competence rather than general cognition. We'll say that it lacks some validity for general cognition. Consider a maze task to measure fine motor skills. Is it reliable? If you do the maze once, do you think you need the same amount of time to finish it a second time? You'll probably be faster the second time just from practicing, even though your motor skills didn't change any. Is it valid? No, a measure must be reliable in order to be valid, so it lacks reliability. But it is probably a more valid measure of memory because they are able to remember how they got through the maze the second time. I'm going to go ahead and skip that one. Validity is whether or not the instrument measures what it is designed to measure. Below are 3 constructs that you can use to evaluate the validity of a measure: face validity, predictive validity, and congruent validity. Face validity is do the questions look like they measure what they are supposed to. Predictive validity is do you imagine that this measure would predict something that it logically should. Then concurrent validity, do you think this measure correlates strongly with something that it logically should? So in face validity, we would look at something like, so let's talk about screening measures in schools. So in USD 383, they use a measure called the SABRS, and that is the social and emotional behavior rating scale, or something like that. And it is used to look at the social emotional ability of kids. And so on face validity, we look at the questions. They probably measure what they're supposed to, so we do pretty good with face validity. In predictive validity, would we think that this would predict something that it logically should? So it's supposed to predict students that are at risk or have some sort of a social emotional issue. And the SABRS does okay in this realm. And does this measure correlate strongly with something that it logically should? So then they would have done validity testings with other measures that measure the same type of thing, and they would see, does it measure adequately against these other measures? And it does okay with there too. So do the questions look like they measured what they're supposed to? What does the question below look like it should measure? Choose the item, blah, blah, blah. I do not feel sad. I feel sad. I'm sad all the time and I can't snap out of it, blah, blah, blah. If you said depression, you'd be correct. It looks like an item from a depression scale, and it is. It has face validity. If someone said that this was from a parental attachment scale, then you could say that it lacks face validity. So in predictive validity, does the measure predict something that it logically should? According to their website, the SAT is the one test that shows the colleges what you know. College admissions officers use this test to determine who will do well in college. What future measures do you expect the SAT would be correlated with? If you said grades in college, you would be right, and the SAT is correlated with that somewhat, so it has some predictive validity. And then we have concurrent validity. Does this measure correlate strongly with something that it logically should right now? Unlike predictive validity, concurrent validity compares measures taken at the same time. So what current measures do you imagine that GPA should correlate with? If you said current test scores and teacher ratings, you would be correct. GPA has some concurrent validity. So when we look at a study, we want to make sure that they report reliability and validity of their measures. So the number one thing that we use to determine this in most of when we talk about the reliability and validity of a measure, Cronbach's alpha is usually the one that is described. So Cronbach's alpha is a measure of internal consistency, that is, how closely related a set of items are as a group. It is considered to be a measure of scale reliability. In general, a score of more than 7 is usually okay. However, some authors suggest higher values of 0.9 to 0.95. And I'm not going to have us use this. So, personality.csv. I don't know if I have that. All right, I'm going to leave that for another time. So, generally speaking, we have these outcome measures that are, if you're doing a group design, we should be looking for measures that have already been tested for liability and validity. And you would note those things in your, so what you would want to do is you would want to, so let's say that I'm looking for SABRS reliability. So I'd be looking for scholarly articles that discuss the psychometric properties of the SABRS, and then we would scroll down. We would determine whether or not this study found it to be reliable and valid, and we would use this study as a citation for it being reliable and valid, and we would probably describe the the results. So we would be looking at we would be trying to find the there's the Cronbach's alpha and then the correlation with the BESS. And so the BESS is the behavior and emotional screening system. So this is looking for concurrent validity. So this is measuring it as being valid. This is related to it being valid. This is related to it being internally reliable. And so we're seeing some pretty high numbers here. And we're seeing these being fairly high, even though they're negative. But those negatives would have to do with the way that the scores are set up. So in the BESS, these things would be negative, and in the SABRES, these things would be positive. But it's showing us that they are correlated with each other. So you would be looking to find a summary within that article and describe it that way. When we use direct observation, we can do a couple of different things, and direct observation is usually going to be done in a single case design. When you're working with small populations, you wouldn't want to do this in a group design just because it would be far too difficult. So we can use automated recordings. This would be things like galvanic skin response, heart rate, blood pressure. And we can use permanent products. These are lasting products. Could be CBM probes, videotaped observations, and classwork. Direct and systematic observation. This is what we typically do, even with some permanent products like videotapes, or video recordings rather. So in this, we would be looking at things like behavior. And so we have different ways of looking at behavior. We can count the number of times the behavior occurs. We can estimate the percentage of times that the behavior occurs divided by the number of opportunities for that behavior to occur. And then we could look at the rate. So this would be the number of times the behavior occurs in a specific period of time. So if we're looking at things like talking out, that could be done with a simple count. It could be done by a percentage. So what we would typically do, and we'll get to this a little bit later, is we would be in this area. We generally don't go by rate unless it's a specific thing where rate makes the more sense. And then we can have time. So if these behaviors happen over time, so if a kid has a meltdown and is crying, we could look at the duration or the amount of time that he is actually crying, or we can look at the amount of time from the introduction of the stimulus to the behavior occurs. So how long from the time that I tell him to get out his math book does he start crying? So count, the assumptions are the time period is consistent and the behavior must have specific beginnings and endings. Examples are grunts and touches. For percentages, the assumption is we have varying number of opportunities. Examples are different numbers of problems on a quiz, different numbers of teacher queries, raising their hand. For example, if the kid is asked to raise his hand before he speaks, we would have a number of opportunities, which would be the opportunities for him to speak and the number of times that he raised his hand before speaking. In rate, the assumption is it's a timed session. So in a 10-minute session, this is not appropriate for teacher-led trials. For example, when a teacher asks the questions. Example, oral reading fluency. So how fast can they get through a passage correctly in a specific amount of time? So how fast, usually when we're doing oral reading fluency or passage reading fluency, we would look at the amount of words that they say in a minute. Duration, the assumption is this thing lasts a specific length of time. Behaviors are not better suited to count and they last longer. Examples are task engagement or being out of seat. And for latency, this is the time from the introduction of a stimuli to the behavior. The assumption a stimuli is presented to which the participant must react to. An example is compliance to a teacher directive. So the teacher says something, how long does it take for them to actually get out their book and do it? So with systems to measure, we can have the total time. So we want to know the total time during a 10-minute observation that the kid is doing something. The assumption is the behavior has a distinct beginning and end, and it lasts long enough to time. Crying For example, crying during a 45-minute love hug. Or we can do time per occurrence, how long the behavior occurs. The assumption is the behavior has a distinct beginning and end. It lasts long enough to time, and we're interested in how long it lasts on average. For example, crying when sent to bed. We have then ways to estimate time. So when we estimate time, we can have whole interval recordings, which means the observation session is divided into equal parts. The behavior lasts across the entire interval. So we have 1 minute here, and we have 0, 10, 20. This doesn't really, so 1 minute goes all the way to the end. So if we're doing 10 seconds, we would expect that the behavior were to last across the entire interval. So this, in order to flag it as happened, it had to happen from the start of the interval to the end of the interval. This isn't a very often used method. And we have partial interval recording, which is used a lot more often. The observation session is again divided into equal intervals, and the behavior occurs within the interval. So it happened here because we're into this interval. It happened here and it happened here. Didn't happen here at all, and it happened here and it happened here. This is a little bit more reliable than the whole interval recording because we're just trying to get a snapshot of how often the behavior occurs. And then we have time sampling, or also called momentary time sampling, which suggests that the behavior occurs at the end of the interval. So we have it here, we have it here, we have it here, and we have it here. So this one is the most oft used and is said to be the most reliable observational method for time sampling. So if we're doing something with academic engaged time or something like that, time sampling in this method is generally the most effective. Then we would determine the reliability of that through inter-observer agreement. So we would have a second person look at the data, and we would do the smaller number divided by the larger number, and that would give us a the smaller number here is the smaller number. So if I said that it only happened 5 times, this person said that it happened 6 times, we would divide 5 by 6 and we would have a percentage of agreement. Then we have timestamps. So we have point by point agreement, the number of agreements matched by time, number of agreements plus non-agreements. So what we're looking at here is that we were looking at an approach where if we have this grid or we have our momentary momentary time sampling or partial time sampling, both of us have to agree each time that it happens, and then we are dividing the point by point agreement by the number of agreements plus the non-agreements. So in essence, the total number of agreements that we could have had. So if we went for 10 minutes, we would have a total number of agreements that we could have done, and then we have the point by point agreement, which is divided by that. And then in time sampling, we make sure our intervals are synced. We do interval by interval agreement, and then we do divide that by the number of agreements matched by time and the number of agreements plus non-agreements. So what we're going to do here is we are going to do some practice in the discussion where we will look at this video of a person giving a TED Talk who has Tourette syndrome. And what I want us to do is start at 20 seconds.
And now for something completely different.
that he just did. We're going to be counting how many times he does that from 20 seconds until, let's say...
That's what I hope this talk will be. So something absolutely...
Let's get a good number on there. So let's do 220. So what we want to do is we want to see how reliable we are. So what I want you to do is in the discussion post, I'm going to post this video, and you're going to look from 20 seconds to 2 minutes and 20 seconds, and you're going to count the number of times that he grunts. And then in the discussion posting, you're going to discuss the amount of times that he grunted, and then you're going to choose one of the other people that it's done this in the discussion post, and you're going to divide your number by their number, and we're going to see how accurate we are. And effect sizes we're going to do later, so that's the end of this part.